Hello class. So in this video, we are going to discuss the last chapter in differential equations, and that is the application of higher order differential equations. So as I have said in the first videos na ginawa natin, we are studying differential equations para makapag-solve tayo ng mga real-world applications. So kumbaga, in the previous chapters, we have discussed first-order differential equations and then their applications. And after that, we have discussed higher order differential equations. And now we're going to apply those methods by analyzing or modeling real life problems. So basically, this video or this chapter will be divided into two parts. The first one ay mga spring mass systems. And the second one is electrical circuits. So, doon muna tayo sa spring mass systems. So we have simple harmonic motion. So consider the motion of an object suspended at the end of a spring fixed on a rigid surface. So ito yung figure na yun. So makita natin dito, we have this rigid surface and then meron tayong mass suspended by a spring. Ito yung spring natin. Now, the mass M is pulling the spring due to gravity and the resisting force of the spring pulls up the mass upward. So, syempre, itong mass na to, nagkakause ng weight in which pinupull niya pababa because of gravity, yung ating object, and then this spring is pulling the mass up. These two forces are equal. The mass will be at the equilibrium position, which is shown dito sa figure A natin. So in this case, class, nasa equilibrium position siya at hindi gumagalaw yung mass at yung object at yung spring natin because their forces are equal. So when the mass at the equilibrium position, there will be no movement on the spring. Now, however, if we displace the mass from the equilibrium position, the spring will oscillate, meaning magmo-move siya up and down. If we remove external factors such as friction, the spring will oscillate indefinitely. So kung wala nang other forces acting into the system, so mainly friction yung main na main na force na nag-act dyan sa sa system natin. Kapag tinanggal natin yun, the spring class will oscillate indefinitely, meaning di siya titigil. So this behavior, assuming yung ganung harmonic motion that is continuous and will oscillate indefinitely, so we can model that behavior using a differential equation. To be specific, a second order homogeneous differential equation with constant coefficient. So ganun class yung pwede natin siyang i-model using this kind of TE. Wherein yung x natin class, we define this as the position of the mass. So, halimbawa, itong sa letter B natin, ang nangyari class is in-stretch natin pababa yung mass natin. So, therefore, meron na siyang displacement from your equilibrium. That is your x. Now, yung M na to ngayon class, mag-move siya up and down from your equilibrium position. So, mag-move siya from M, then babalik siya dito sa taas, and then pababa ulit, and so on and so forth. Removing external factors, indefinite yung oscillation na mangyayari. Now, since yung x natin will be a function of time, let us denote the displacement of the mass from the equilibrium as x of t. Because at any given time, nag-change yung position ng x natin kapag meron na tayong oscillation. So for spring mass system, it is customary to adopt the convention that is displacement away from the rigid surface. If this is your rigid surface, displacement away from that surface is positive. And displacements toward the rigid surface is negative. So, kapag pababa ang movement, that's positive. Kapag pataas, that is negative naman. So, thus, for the specific spring system, displacement below the equilibrium position is positive. And displacement above the equilibrium position is negative. So, if this is your equilibrium position, any movement pababa is positive and any movement pataas from your equilibrium position is negative. If we analyze the forces acting on the mass, so we will come up with the force of gravity. So now, if we will check kung ano yung force na nag-act dun sa mass, this is just the gravity. its mass and the gravity. This now equates to the weight, which is the force at which the object is being pulled to the Earth's center. And that is your weight. And yung weight nating class, or the force due to the gravity, we can define it as mg. So, simple physics lang. So, mass times the acceleration due to gravity. Na yung acceleration due to gravity natin, in terms of feet, that's 32 feet per second squared kapag English, and kapag metric tayo, that's 9.8 meter per second squared. So now, aside from the weight, may isa pa tayo na-establish na force na nag-work dun sa ating system, and that is the force by the spring, which is opposite the direction of the weight. So the resisting force of the spring pulling the mass upward, this is known as the restoring force. So restoring force, is a force that brings a body to its equilibrium position. Kaya ang restoring force yung tawag. So the definition for the restoring force class, this can be defined using Hooke's law. So yung Hooke's law class, it states this one. Ito yung kanyang definition. That is, the restoring force of a spring is proportional to the displacement as it acts in the opposite direction of the displacement. So thus, ang restoring force natin, F, is equal to negative K times X. This is not K function of X, no, this is K times X. Where K is a positive constant, known as the spring constant in newtons, meter, and X is the displacement. Now, if we have these two forces acting on the system, we can use Newton's third law. Or pwede rin naman na Newton's first law. Or, di ba yung the sum of the forces are equal to zero? Or yung Newton's third law that for every equal action, there's an complete and opposite force. And we can define that as W, or the weight, is equal to negative F, which is your restoring force. Substituting your weight and your negative F, that is mg for W, and that's negative kx, so positive kx, that is your restoring force. So therefore, nakagawa tayo ng relationship class ng mg, k, and x. So we have now a relationship of mg, k, and x. So ito yung dalawang force na yon. We have one force going up. So negative natin yung F na yon. Since it's going upward, since ang customary natin ay yun nga, pagpataas from your equilibrium position, that's negative. And yung weight natin is ginawa nating positive. So we have this equation now. So X class is distance. So therefore, if we take the first derivative of X with respect to time, we will get velocity. And if we again take the derivative of the first derivative, we will have the second derivative of distance, and that is acceleration. So, ibig sabihin class, sa equation natin, we have g, and g is an acceleration. So, therefore, pwede na lang natin palitan yung g natin ng second derivative of x. Diba? So, therefore, we will have m is equal to d squared x over dt squared is equal to kx. Pero ito yung previously is g mo. Take into consideration that dx over dt, first derivative of x with respect to time, is velocity. And if you take again the derivative of this one, you have d squared x over dt squared. This is now your acceleration. This is now an acceleration. So therefore, we will arrive at this equation. So simplifying natin to, ginawa natin x double prime na lang. So we will have x double prime plus kx is equal to 0. This is from the equation ng ano natin kanina, ng anong tawag dito? Equation ng force and ng weight natin. So we arrive at this equation. So this is a second order homogeneous linear differential equation. Ito na ngayong class yung equation natin na gagamitin. So kung second order na differential equation siya, we can just use or get the auxiliary equation para makuha natin yung general solution. So for the auxiliary equation, take note, ang ginagamit natin previously ay m. But this time around, we will use lambda. So lambda talaga yung ginagamit. Kaso, since di naman natin, kumbaga mahirap i-type kasi yung m, ay yung lambda before, so M yung ginamit natin. So ginagamit din talaga yung M for auxiliary equation. But for this discussion, ang gagamitin natin is lambda para hindi nakakalito with M kung yan ba ay mass or ano. Kasi baka magtanong kayo ba't lambda yung gamit natin ngayon? Eh dati M yung gamit natin. So iniba lang natin for the sake of to avoid confusion. So therefore, we will have M lambda squared plus K is equal to 0. Now, so taking the roots class, we will have, kasi ang nakuha nating equation is quadratic equation. Kumbaga, and if we take the auxiliary equation, so we will have this one. So taking the roots, we will have lambda squared is equal to negative k over m. So yung roots natin is plus or minus square root of negative k over m. Now, if we take into account our assumptions that m and k are positive, we then realize that the roots of the equation is imaginary. So if we let omega, gawin nating omega is equal to negative k over m, then ang lambda natin is equal to plus or minus omega I, wherein I natin is imaginary or means imaginary or square root of negative 1. So assuming positive ang k, positive ang m, ang mangyari class, this is a square root of a negative, so that is imaginary. So that is why express na lang natin itong k over m as ang positive square root of positive k over m, gawin natin siyang omega. So ang maging roots natin ngayong class will be equal to plus or minus omega I. Now yung omega natin, yun yung tinatawag natin na angular frequency. So therefore, ang general solution natin will be, so this is still based from our discussion nung nakaraan, that is, kapag imaginary ang roots natin, that is, x of t is equal to c1 cosine omega t plus c2 sine omega t. So the sine and cosine terms of the function indicates oscillation. So as we have discussed kanina, yung ating spring mass system or yung mass natin will oscillate indefinitely. So kung ganun class yung case, ibig sabihin continuous lang na magmo-move yung position ng x natin. And kung magkakaroon tayo ng continuous movement ng x natin, we will need a sine or a cosine function. That is why sa general solution natin, we have sine and cosine terms. Now, the sine and cosine terms of the function can also be written as ganito. So we will have x of t is equal to a cosine omega t plus this symbol. Ano mo ito yung tawag? This is the phase angle kasi. So this is acquired using trigonometric identities and assumptions that this one, yung a natin na to, that's the square root of c1 squared plus c2 squared. That is the amplitude of your oscillation. Geometric mean lang nung dalawang constants natin. Angular frequency natin is, ito dinefine naman natin kanina, square root of k over m. And this one is our phase angle. Now, cosine of our phase angle is equal to c1 over a. And ang sine naman ng ating phase angle will be c2 over a. So this is how we define it. Pero actually, for definition purposes lang to. Pero okay na tayo dito. Kasi 'di ba, ang aim lang naman natin is to solve for differential equation. So most of the time, titigil na tayo dito. Pinakita lang natin how it can also be expressed in a different way. Now, this type of motion class, ang tawag natin dyan is simple harmonic motion. Simple because it's we remove all external factors and we only look at the forces acting on the spring that is relevant to the oscillation. It's a harmonic motion since continuous siya. So the period of oscillation class for the mass attached to the spring is given by T is equal to 2 pi over omega. So this is our kung gusto mong malaman yung period, which is the time it takes for one oscillation to occur, that is just equal to this equation. So that's 2 pi over square root of m over k, or since meron na tayo nitong, pwede natin ito express as omega, so that is equal to 2 pi over omega. Now, pwede rin natin itong i-apply class sa isang horizontal spring on a frictionless surface. Ang mangyayari dito, class, is instead of weight yung isa, we have force din kumbaga. Imbes na weight yung isa, we have another force. So if this is your rigid surface, um, displacement going away from the rigid surface, that's positive. And then displacement going in or papunta sa rigid surface, that is negative. So, assuming na wala tayong friction, frictionless yung surface natin, this mass will oscillate indefinitely kung maglagay tayo ng external force para ma-stretch siya. Ayan. So, para mas maintindihan natin, i-apply natin siya sa problem. Again, ang kailangan lang naman nating tandaan dito is our general or our differential equation kapag minodel na natin yung spring mass system natin. So, for this example, an object daw weighing 2 pounds stretches a spring by 6 inches. Find the position of the mass if the spring is released from equilibrium position with an upward velocity of 16 feet per second. What is the period of motion? So, yun yung problem natin. Now, when trying to answer this kinds of problems, you have to be very careful kung ano yung ginagamit ng units. So, in this case, class, pounds and inches, this is English. Diba? But take note, we need to be uniform. Dito is feet yung gamit. And alam naman natin, kapag English, ang given yung gravity natin, feet per second squared. Yan. So, we have to take note of that. Kasi ang given dito is inches. So, later on, we need to convert that into feet pa. Okay, let's start. So, nilagay ko yung problem sa taas para may reference tayo. Now, the equation of the spring, class, is ito. So, nakuha na natin ito kanina. That is mx double prime plus kx is equal to 0. So, we need to find the values of your unknowns muna dito or yung mga part ng equation na hindi natin alam kung ano yung value. If we look at the problem, we have the following things that are given. Ayan. I-write ko pala yung question. Hindi ko pala siya na-edit for a while. Yan. So, hindi ko pala na-edit ng mabuti. Yan. Okay. So, inayos ko lang yung question dun sa taas. So, yung mga given natin dito, class, is we have this one. So, the object daw is weighing 2 pounds. So, weighing 2 pounds, diba? So, nagwe-weigh siya ng 2 pounds. Kapag ganun, class, then ibig sabihin, alam natin ang tinutukoy dyan is actually weight. No? Weight yung tinutukoy natin and hindi mass. So, ibig sabihin, hindi tayo given ng mass, but given tayo ng weight. And yung weight natin, class, is 2 pounds. Now, we also have this statement that it stretches the spring daw by 6 inches. So, therefore, ini-stretch niya yung spring natin by 6 inches. So, that is our x. So, that's displacement. And that x, class, that's 6 inches, pero gawin natin in terms of feet. So, that is 0.5 foot. Yan. So, sabihin yan, class, if we have this equation, we can, if we have this given, meron na tayong mga parameters na pwedeng ma-solve dun sa ating problem. To be specific, we can solve for the mass and we can solve for K. So, let us first solve the mass. We can just simply use the formula for the weight and that is just mg. So, weight natin is 2 pounds, m natin is unknown, and g natin is 32 feet per second squared. So, substituting that to the equation, we will arrive at m is equal to 1 over 16. That is our mass. Now, we have to solve for k. Now, to solve for k, we can just use Newton's third law of motion. Actually, na-derive naman natin to kanina. That is that mg is equal to kx. We know mg. mg is just weight and given na yan dito, that's 2 pounds. And yung x nating, class, that is the displacement, which is 0.5 0.5 feet. Kasi sinabi dito na ini-stretch niya yung spring natin by 6 inches. Meaning, yung normal size niya na-extend or na-stretch siya ng additional 6 inches because of the weight natin. So therefore, that is 0.5 feet. Now, substituting that to the equation, mg is equal to weight, that's equal to 2 pounds. Then that is equal to k times your distance or your displacement, x is 0.5. So therefore, ang k natin is 4. Substituting this to your equation, we will arrive at 1 over 16 x double prime plus 4x is equal to 0. Simplify natin. Multiply both sides by 16. Multiply both sides by 16, we will have x double prime plus 64x is equal to 0. This is now your equation, your differential equation. Now, we can now take the general solution. So this is second order homogeneous linear differential equation with constant coefficient. So, alam natin that the general solution for this one class is, kasi ang lalabas dito ay imaginary roots. So, we will have x of t is equal to c1 cosine omega t plus c2 sine omega t. Wherein, yung omega t natin is equal to to the square root of k over m. K natin is 64, m natin is 1. So, therefore, we will have the square root of 64 and that's 8. So, that is our omega. Now, substituting that, our general solution is x of t is equal to c1 cosine at plus c2 sine 8t. Now, we have to find the general solution. To find the general solution, ayan, ayusin ko lang ulit. And to find the general solution, the particular solution pala, we need to substitute our initial conditions. Now, from our nakuwang general solution, we have two unknowns or two constants rather, that is C1 and C2. So, kung ganon, we need two initial conditions then. Now, saan tayo kukuha ng initial conditions? Well, that is from the statement. So, find the position daw of the mass if the spring is released from equilibrium position with an upward velocity of 16 feet per second. So, yun yung gagamitin natin ngayong class to find the general kung ano yung initial conditions natin. Now, ang sabi dito class, the spring daw is released from equilibrium position. So, kung ni-release siya from equilibrium position, it means class na that is at the moment na magsa-start pa lang yung system. If that is the case, then that is your x at t is equal to 0. Now, asan yung position ng x at t is equal to 0 at equilibrium position? So, therefore, that is at 0 at x is equal to 0. So, that is our first initial condition. So, that is at t is equal to 0, x is at equilibrium position or at 0. Substituting this, we will have x natin is 0 is equal to c1 cosine 8 times 0 plus c2 sine 8 times 0. So, sine of 0, so tandaan nyo, kapag sine 0, that's 0. Kapag cosine 0, that's 1. So, therefore, we will have c1 is equal to 0. Now, ang tanong, saan tayo kukuha ng isa pang initial condition to get the value of c2? Now, if we look at the problem, meron daw upward velocity na 16 feet per second yung system natin, yung mass natin. But saan tayo kukuha ng velocity? Wala naman tayong equation ng velocity. Doon sa equation natin, meron ba tayong parameter na velocity? Wala. Diba? But remember class, that the first derivative of distance or displacement is velocity. So, kung ganun pala yung case class, if we have an equation for displacement, we can just take the first derivative para maging expression siya ng velocity. So, in this case class, yung itong x of t natin, if we take the first derivative, we will arrive at the equation of the velocity. And we can now use this initial condition that it was released with an upward velocity of 16 feet per second. That is, at t is equal to 0, ang velocity niya ay 16 feet per second. So if that's the case, class, we can now substitute that to our equation. So this is your equation for velocity. You need to get the equation for displacement. So you need to get the first derivative para maging velocity siya. Now, another thing that you have to take note is that the velocity daw is moving upward. So moving upward, it means it is moving towards the rigid support. And if it's moving towards the rigid support, that means this is a negative na vector. So negative dapat yung velocity natin. Now, if we take the first derivative of our xt, that is x prime of t is equal to negative 8 c1 sine 8t plus 8 c2 cosine 80. That is the first derivative of this one. We can now substitute negative 16 there. Plugging it to the equation. Oops. Ayan. So plugging it to the equation, we will have x prime of 0, that is equal to negative 16. We will have negative 16 is equal to 8, negative 8c1 sine 8 times 0 plus 8c2 cosine 8 times 0. So this will be equal to 1 and this will be equal to 0. So matitira na lang class is negative 16 plus 8c2 times 1. And divide natin yon, we will have c2 is equal to negative 2. So therefore, we can get our particular solution. And that is x of t is equal to negative 2 sine 8t. So you can now describe the position of the mass at any given time using this equation. So halimbawa, at t is equal to 2 seconds, asan ang position ng x? So you just substitute this to this equation. Now, for this particular solution class, given na maglalagay ka ng value ng t, you can get different values of x. And to be specific, ang makukuha nating value ng x dito may either be positive or negative. Kapag ang nakuha mo ay positive, ibig sabihin ng class at that moment class ay below equilibrium point yung position nung ating object or nung mass natin. At kapag negative siya, meaning mas mataas siya sa equilibrium point natin. So if this is your bayan, ang pangit ang drawing ko. If this is your surface and this is your spring and this is your mass, ang tendency class na mangyayari dyan ay mag-move siya mag-oscillate, mag-move to akyat tapos baba. So yung movement nun class, halimbawa, tataas muna yung mass natin and then bababa and then tataas ulit and then bababa, etc. etc. So this is the movement niya with respect to time. So at any given point class, if this is your equilibrium position, yung x mo dyan ay 0. And then if you are above the equilibrium, ang x mo ay negative. If you are below, ang x mo ay positive. Now, it is in the problem, tinanong din, what is the period daw of the motion? Oh, this is easy to get because we have the formula lang, and that is 2 pi over omega. Substituting natin yan, class, we will have t natin or period natin is equal to pi over 4. So, ibig sabihin ng period natin, this is the amount of time that it will take to complete one cycle. So, after pi over 4, nakapag-move na ngayon, class, yung mass natin ng isang buong cycle. Ayan, another example. Sorry. Ayan, so a spring daw has a mass of 2 kilograms and a natural length of 0.5 meters. A force of 25.6 newtons is needed in order to maintain the spring stretched at 0.7 meters. If the spring is stretched to a length of 0.7 meters and then released without any initial velocity, find a function of time that will tell the position of the mass at any given time. So for this one class, this is a very simple problem. Similar lang nung kanina, we are being asked to get a function of the displacement with respect to time. So we'll just repeat the same process. But again, ang isa natin kailangan gawin dito is analyze talaga yung problem para malaman natin yung mga given. So in this case, class, it is specified in the problem that the mass is 2 kilograms. So kung mass to, ibig sabihin, that's not weight. That's just mass. So therefore, we need to get pa the value of the weight. Now, isa pang tingnan natin dito is natural length natin is 0.5 meters daw. And na-stretch siya into 0.7 meters. So therefore, we can also get the value of our x in here. And that is 0.2 meters. Now, if the spring daw is stretched to a length of 0.7 meters and then released without any velocity, so ibig sabihin nito class, it just means na at time is equal to 0, naka-stretch ka at 0.7 meters. So at t is equal to 0, you have a value of x. And at that time, wala kang initial velocity. So if you take the first derivative, your x of t, x prime of t is equal to 0. Ayun. So yun yung mga kailangan nating tandaan na or i-watch out ng mga terms doon sa ating problem. Now, ayan, proceed na tayo with solving. So, the equation of the spring class is we have mx double prime plus kx is equal to 0. We have to find the values na wala. Tayo dyan. The mass is given, that's 2 kg. However, hindi pa rin natin alam yung k. Now, to find k, pwedeng gamitin natin yung mg is equal to kx. Pwede rin naman na Hooke's law na lang. Remember, in Hooke's law, that's f is equal to negative kx. Now, when the spring is being pulled down by force, the spring is also exerting an equal force pulling the string up. So this is the resisting force, which is 25.6 Newton. Since it is pulling the spring up, thus it is a negative na value. So x is the displacement of the spring for its natural length. Thus, that's x natin is equal to 0.2. So, ang natural length mo ay 0.5, but the force is hinila ka ng hanggang 0.7. So, therefore, na-displace from the equilibrium position yung yung mass mo by 0.2 meters. So, substitute na natin ngayon dyan. We have, ang resisting force natin is how the force that is pulling you or maintaining the position, which is your restoring force. Tapos, up siya. So that's why it's negative. So we have negative 25.6 is equal to negative k times x natin is 0.2. We have now the value of k natin, and that is 128. So we can now substitute. So ang differential equation natin class will be 2x double prime plus 128x is equal to 0. Sinubstitute lang natin yung m tsaka yung k natin. Now, general solution class is x of t is equal to c1 cosine omega t plus c2 sine omega t. So, we get the value of omega. So, we need to use our formula, which is the square root of k over m. So, our angular frequency natin will be the square root of 64, which is just 8. So, omega is 8. Substituting that, we will arrive at our general solution, that is x of t is equal to c1 cosine 8t plus c2 sine 8t. So, kaparas lang din na nakuha natin kanina. Now, we have to plug in our initial conditions para makuha natin yung particular solution. Now, ano yung mga condition dito? So, that is class, ito. If the spring daw is stretched to a length of 0.7 meters and then released without initial velocity, so that means class at time is equal to 0, meaning yung magsa-start pa lang yung system mo, in-stretch siya to 0.7 meters. If your equilibrium position is 0.5, meron na agad siyang displacement na 0.2 at the start of your system. So thus, we have this initial condition, x of 0 is equal to 0.2. Substituting that, we'll have 0.2 is equal to C1 cosine 8 times 0 plus C2 sine 8 times 0. So this is equal to 0 na. We will arrive at C1 is equal to 0.2. Now we have we need another initial condition. So, anong initial condition yung pwede natin gamitin? That is this statement class that if the spring is stretched down and released without any initial velocity, so meaning at the start of your system, that is at t is equal to 0, your velocity is 0 kasi wala kang initial velocity. So, kung ganun yung case, we know that x prime of 0 is equal to 0. That is our second initial condition. Now, in order for us to substitute that, we need to get the first derivative muna. So, the first derivative ng equation natin of x of t, so that is just equal to x prime of t is equal to negative 8c1 sine 8t plus 8c2 cosine 8t. Substituting, we will have 0 is equal to negative 8c1 sine 8 times 0. This will now be equal to 0 plus 8c2 sine 8, 0. That's a cosine 0 is equal to 1. So, we will now arrive at c2 is equal to 0. So, therefore, yung particular solution natin is x of t is equal to 0.2 cosine 8t. Or para wala tayong decimal, that's 1 over 5 cosine 8t. So, ito ngayong class yung particular solution natin. You can now find the position of x at any given time using this equation. Now, kung mapapansin din class, itong equation na to, no matter ano ang value ng time mo, you will always have a value of x. So, therefore, kahit na yung time mo ay umabot ng 1,000 seconds na yan or kahit gano'n na yan katagal, the oscillation will continue. Because the assumption natin class, or we will always have a value of x because our assumption is that we removed all the external factors, kaya ang oscillation niya ay indefinite. Now, yung indefinite na movement or oscillation, hindi naman yun yung practical, di ba? Hindi naman yung natural na nangyayari. So, kadalasan class, we have, to be specific, air friction. Yung air friction, sobrang nakaka-apekto siya sa pag-move or sa time at which mag-oscillate yung system natin. Di ba nakakita naman na siguro kayo ng mga oscillations, for example, pendulum, o kaya mga spring din na nagmo-move up and down. So kapag tagal-tagal ng time class, ang tendency titigil din yung movement nila. Now, that is the more realistic na system class. Now, we can also model that. Ang tawag natin sa mga ganun class is damp vibrations. So, damp oscillations, damp vibrations. So, in the previous discussion, our assumption is that no external forces are acting on the spring. Thus, it oscillates indefinitely. So, ang gagawin natin ngayong class is we will have, aside from the two forces na diniscuss natin kanina, magdadagdag pa tayo ng isa. And that is known as the damping or the damping force. So, yung damping natin class, this could be result of friction, air resistance, or an actual damper. Kung intention mo as i-damp mo talaga yung ating i-dampen mo talaga yung oscillations natin. So, kaya nga damping yung tawag kasi parang pinapatigil mo yung oscillation natin. So, ito yung isang, ang tawag dito, dashpot. Actually, alam niyo yung sa mga bisikleta, di ba parang, na lubak ka, yung mga bisikleta na medyo mamahalin, yung mga may hydraulics, may mga dashpot yan. Or yung mga bisikleta na may mga dashpot. Para, halimbawa, bigla kang nalubak, tapos bababa yung mo. Ang tendency class is unti-unti i-absorb niya or i-dampen niya yung force, kumbaga. At kapag dampen niya yung force, ang tendency is mababawasan yung oscillation. So, hindi ka tatalbog ulit ng tatalbog. So, yun yung purpose niya. So, essentially, class damping is frictional force. So, halimbawa, usually frictional force with the fluid. Minsan, meron tayong oil na nilalagay o kaya naman, air lang yung damping natin. So, thus, we assume that it is proportional to the velocity of mass and acts in the opposite direction. So, since friction siya, it acts in the opposite direction kasi pinipigilan niya yung oscillations natin or yung movement ng mass natin. So, we can define that as F, D na lang para damping. Damping force is equal to velocity times b, wherein yung b nating class, that is the proportionality constant natin. Now, if we consider this damping force class, we now have three forces acting on the system using first law, or not, hindi pala to for first law, sorry. So, alam lang natin naman, di ba, that the sum of the forces acting on the system is equal to 0. So, if we add yung BV natin, we will arrive at this equation, mg plus BV is equal to kx is equal to 0. But then, g is natin, double is the second derivative of x. And v natin, that is the first derivative of x. So, that is x prime. So, therefore, palitan natin yon, we will have mx prime plus bx, mx double prime plus bx prime plus kx is equal to 0. So, this is, yet again, a differential equation that is homogeneous linear differential equation with constant coefficients din. Now, how do we find the general solution? We just take the auxiliary equation. So, the auxiliary equation nating class is lambda squared plus m lambda squared plus b lambda plus k is equal to 0. Now, we need to find, this is a quadratic equation. So, we can find we can find the values of r lambda or of the roots using quadratic formula, which is lambda is equal to negative b plus or minus square root of b squared minus 4mk over 2m. Now, take note class, hindi natin masasabi kung yung resulting lambda natin is positive, negative, etc. Remember, kapag nagsosolve tayo ng second order differential equation, we have to take into consideration kung sila ba ay the roots ba ay real and distinct, meaning real number sila tapos parehas magkaiba ng values. Are they real but not distinct or repeating? Or are they imaginary or complex conjugate? So we need to consider all of those. So therefore, just like in second order linear differential equations, we consider all three cases natin. And yung each case na yung class, meron silang pagkakaiba lahat. So the first case natin class is yung tinatawag natin na overdamp vibrations or oscillations. That is when b squared is greater than 4mk. So we say that the system is overdamp. So kapag overdamp ang ating system, ang general solution natin will be x of t is equal to c1 e raised to lambda 1t plus c2 e raised to lambda 2t. In short, kapag overdamp ang vibrations natin or kapag ang roots natin ay real, ano yung letter na yan? Ay real and distinct, we have overdamp vibrations. So, ito yung movement class ng overdamp na vibrations natin. So, if this is a graph class of t and displacement, so time and displacement. So, but in this case class, dapat baliktad to. So, hindi natin pa siya nakabaliktad. Sa convention kasi natin, ito yung positive, ito yung negative. But para hindi na kayo malito, ang ginawa natin is positive yung pataas, negative yung pababa. So, kung ganun nga yung class yung case natin, if this is your x, this is the position, kumbaga imagine nyo lang may spring dito. Ano ko ba ito-draw? This is your end na lang of your rigid surface. And then, this is your spring and this is your mass. And your mass, ang equilibrium position niya ay itong point na to. Ayan. Now, naglagay tayo ng external force. Ang tendency, nagkaroon tayo ng oscillation, but may damping. So, ang nangyari ngayong class is, halimbawa, nag-move at this point yung mass mo. Now, kapag nag-move yan, syempre, mag-move siya ulit pababa. So, pag nag-move siya pababa, so, lumagpas siya sa equilibrium point natin. Pero, pag lagpas na sa equilibrium point, bumalik na siya agad to nagkaroon na ulit tayo ng movement pataas. And then, after ng movement na pataas na yung class, konti lang yung movement niya, dumiretso na siya or bumalik na siya at its original na equilibrium position. So, that is an overdamp by vibration. So kung napansin natin class, in simple harmonic motion, indefinite yung movement ng ating mass. Hindi siya nagsa-stop. But if we consider the friction or the damping force, nadadamp yung or nadadampen yung natin, yung force or yung movement ng mass natin. At instead of moving up, down, nag-move siya class ng ganito na lang. Ang movement niya class is down, tapos up ulit, tapos steady na siya at your equilibrium position. So that is overdamp vibrations. So overdamp vibrations class, they do not oscillate. They simply move back toward the equilibrium position. So it may have one change of direction but hindi siya nakakompleto ng isang cycle. So ito nga yung graph natin na yun. So kung ganun pala yung case, we just have to solve overdamp vibrations and treat them as second order linear differential equations with constant coefficients, tapos real and distinct yung roots natin. Apply natin sa problem. So a spring class 10 feet long, extends to a length of 15 feet and 4 inches when an object with a weight of 16 pounds is attached to it. If the spring is immersed in a fluid with a damping force equal to 2.5 times the instantaneous velocity of the mass, find the equation of the motion if the mass is pushed upward from equilibrium position with an initial velocity of 5 feet per second. So that is our problem. So kung napansin, similar lang siya on how the problems earlier were defined sa simple harmonic motion. But this time around, may nadagdag tayong damping force. And yung damping force daw natin, it's 2.5 times the instantaneous velocity of the mass natin. Now, tingnan natin kung paano natin siya may apply while solving the problem. So, the problem is very similar. Ito, nasabi ko na to kanina. May damping force lang. And this damping force class, na binanggit dito, that's 2.5 daw. So, remember, ang damping force natin is velocity times the B, which is our proportionality constant. And in this case, class, given na yung proportionality constant natin, that's 2.5. So, di ba, 2.5 times ng instantaneous velocity mo. So, that is your B. Your B, because it's 2.5 times your velocity, which is, di ba, ang formula natin for the damping force is BV, di ba? BV, B times velocity. So, therefore, ang proportionality constant natin is yung 2.5. Now, we solve now for the spring constant kasi hindi naman given yung spring constant natin. So, we have to solve for that. Wait, pakita ko muna yung equation. Ayan, hindi ko pala sinulat. Sige, susulat ko na lang. So, remember, class, that our equation for damp vibrations is we have mg plus bx, yung buo na. We have mx double prime plus bx prime plus kx is equal to 0. So, we need to find b, given na yan. M, we can also get that, and x, we can also get that. So, we need to solve for the value of m and the value of k natin. Now, to solve for the value of k muna, so, gamitin natin yung sinabi that the spring daw is extended to a length of 15 feet and 4 inches. So, ganun, 5 feet lang siguro to, 5 feet. Ayan. Hindi, tama. O, tama. Ayan, 5 feet and 4 inches. So, therefore, yung x nating class is 16 over 3 feet. And ang gagamitin nating formula dito kasi is mg is equal to kx. Ayan, so that's what we're going to use. However, hindi natin alam yung mg, but mg is equal to weight. And given yung weight dito, it weighs daw 16 pounds. So, therefore, we can use mg is equal to 16 pounds. So therefore, we will have 16 is equal to k times 16 over 3. Ang k natin, class, is 3. Next, we need to solve for m. To solve for m, we just use weight. So we have W is equal to mg. Tayo ay naka-English. So ang g natin is 32 feet per second squared. So substituting, we will have m is equal to 1/2. Substituting this, we will arrive at our differential equation, and that is 1 over 2 x double prime plus 2.5 x prime plus 3x is equal to 0. This is now your differential equation. You can now get the general solution. Now, to make it easier, simplify natin. Multiply the whole equation by 2. We have x double prime plus 5x prime plus 6x is equal to 0. Now, we take the auxiliary equation. We have lambda squared plus 5 lambda plus 6 is equal to 0. Let's use the quadratic equation to get the roots, and we will arrive at lambda 1 is equal to negative 2 and lambda 2 is equal to negative 3. So, nasa sa inyo kung gusto nyo gumamit ng quadratic formula or pwede rin naman na mag-factoring kayo. Now that we have our roots, we can find the general solution, and that is x of t is equal to c1 e raised to negative 2t plus c2 e raised to negative 3t. Now, before natin mag-apply ng initial condition, ang isang gusto kong mapansin nyo is, in this equation class, it is e raised to negative, e raised to a negative number. And as t passes, ano yung mangyayari? So, as time passes class, yung value ng t natin, lalaki ng lalaki yan. So, therefore, palaki rin ng palaki yung negative exponent natin. And as your negative exponent rises, what happens to the value of your term? It approaches 0. So, ibig sabihin, class, kung titingnan natin itong equation na to, it is approaching 0. Which is just tama lang. Kasi di ba, ang damp na vibrations natin or overdamp na vibrations natin, ang kanyang movement is ganito. Yan. So, as time passes, ang nangyari, class, is our x approaches 0, which is evident in this equation or general solution natin for the problem because it is raised to a negative number. So, kung raised siya to a negative number, so ibig sabihin, palit ng palit yung value na, and there will come a time na kapag sobrang laki na nung value ng t mo, sobrang negative na nung exponent mo, your x will just be approaching 0 or will just stay at 0. Now, applying the initial condition, we have, ang initial condition natin dito, class, ay, ano ba yung sabi dito? Ayan. So, find the equation of the motion daw if the mass is pushed upward from equilibrium position. So, ibig sabihin, nagsimula yung system mo at time is equal to 0 at yung x mo ay yung mass mo ay nasa equilibrium position. So, therefore, at t is equal to 0, x is equal to 0. So, substituting that, we'll have 0 is equal to c1 e raised to negative 2 times 0 plus c2 e raised to negative 3 times 0. So, e raised to 0 is 1. So, matitira na lang is c1 is equal to c2. Hindi yan c squared This is c2. Now, another initial condition is using the velocity. Also, take note, sinabi din that it was pushed upward from equilibrium position. So, therefore, your velocity is negative. So, in order for us to apply the second initial condition, we need to first take the first derivative of x of t. So, this is your x of t, that's c1 e raised to negative 2t plus c2 e raised to negative 3t. Kunin natin yung second derivative, first derivative, that's x prime of t is equal to negative 2c1 e raised to negative 2t minus 3c2 e raised to negative 3t. So, substituting the initial condition, that is at x prime of 0 is equal to negative 5 since upward siya, kaya negative. So, we have negative 5 is equal to 2c1 e raised to negative 2 raised to 0. So, this will be 1. Ito rin, this will be equal to 1. So, matitira na lang ng class will be negative 5 is equal to negative 2 minus negative 3. We will have, but C1 class is equal to negative C2. So therefore, pwede nating pagparehuhin tong dalawang to. And we will have C1 natin is equal to negative 5. So therefore, C2 natin is equal to positive 5. And we can now substitute sa ating general solution. Now, ang particular solution natin ngayong class is x of t is equal to negative 5e raised to negative 2t plus 5e raised to negative 3t. Now, that is our answer. Now, in this equation class or particular solution, try nyo maglagay ng mga value ng t. So, kapag lagay kayo dyan ng value ng t, tapos ang nilagay nyong value ay mababa, may makukuha kayong value ng x. Pero kapag ang nilagay nyong value ng t ay mataas na, meaning, andito ka na, ang team mo na, mga nandito sa point na to, ang makukuha mo ay approaching 0 or sobrang liit niya na value. Now, next is, we have the critically damped vibration. So, since pare-paras lang naman yung process class, no, we only have one example for each case. Kasi kumbaga, for each case, dapat, ano na tayo, may kumbaga, ito na yung bawat example. Each example for each case, kumbaga marami tayong example na binigay. Yan. So, proceed naman tayo, class. Tapos na tayo sa overdamp. We now have the critically damped vibrations. So, kapag critically damped yung vibrations natin, this is when your B squared is equal to 4 mk. In short, ito ay kapag ang roots mo ay real and repeating. So, if your roots are real and repeating, this is also case 2 kapag second order linear D yung pinag-uusapan natin. Ang iyong general solution is, ang iyong roots ay real and repeating. So, therefore, ang general solution mo will be x of t is equal to C1 e raised to lambda 1t plus C2t e raised to lambda 1t. 1 din pala. Lambda 1t because same nga sila ng lambda. Wherein lambda nating class is less than 0. So, lagi na negative. Kapag damp ang ating vibrations, lagi class na negative yung exponent natin. Because our equations are, or our graph class is approaching 0. So, ito yung graph ng critically damped ng mga vibration. So, ganun din. From a displaced na movement, tapos babalik din agad siya sa equilibrium. Now, this is practically impossible din, class, to fine-tune the parameters because it's hard na magawa mo sa physical system na yung B squared mo at yung 4mk mo are exactly equal. So, apply natin sa problem. A block with a mass of 1 kilogram stretches a spring by 20 meters from its equilibrium position. So the mass is submerged in a liquid or fluid that dampens the system equal to 14 times the instantaneous velocity of the mass. Find the equation of the position of the mass if it was released from equilibrium with an upward velocity of 3 meters per second. So at 0.2 second, what is the instantaneous velocity? So at this point, class, this is already the fourth problem na sinolve natin about springs. Dapat nagkaka-idea na tayo, no? Familiar na tayo paano ba ina-identify yung mga given. So let's solve. So first, remember our equation is m x double prime plus b x prime plus kx is equal to 0. So, yung m ba natin ay given? Yes, m is given. Sinabi na mass siya. It's 1 kilogram. So, be careful doon na. Pag sinabing mass, mass yan. Pero kapag sinabing weighing, it weighs ganito, iyon ay weight siya. So, that's mg na yun na buo. So, given yung m. Now, also given yung b. Ang b natin is 14 times daw the instantaneous velocity. So, 14 times x prime mo, or the velocity. So, 14 yung b natin ngayon. So, we need to solve for k na lang. So, let's use this equation. Mg is equal to kx. Mass natin is 1 kilogram. Gravity natin is 9.8 meters per kilogram pala. 9.8 meter per second squared is equal to 0.2 times k. So, yung natin, yung x nating class is 0.2 because ang sabi dito ay ito, the 1 kilogram stretches down the spring by 20 meters from its equilibrium position, or 20 centimeters. And 20 centimeters is 0.2 meters. So, K natin is 49. So, our differential equation is then x prime plus 14x, x double prime plus 14x prime plus 49x is equal to 0. The auxiliary equation class is lambda squared plus 14 lambda plus 49 is equal to 0. We take the roots. The roots class is lambda 1 is equal to lambda 2 is equal to negative 7. So, kung napansin, we have two roots, lambda 1 and lambda 2, but they are equal to each other. They are real numbers, but they are repeated. So, therefore, ang general solution natin is x of t is equal to c1 e raised to negative 7t plus c2 t e raised to negative 7t. Now, we need to find the particular solution. So, in order for us to do that, we need to substitute the initial condition. Now, hanapin natin yung initial condition doon sa problem. So, ang sabi, like, it was released daw, the mass was released at equilibrium with an upward velocity of 3 meters per second. So, ibig sabihin, class, at t is equal to 0, ang x mo is at equilibrium. So, that is x is equal to 0. Also, at t is equal to 0, you have an upward velocity of 3 meters per second. So, ibig sabihin, meron kang pataas na velocity. Substitute muna yung first initial condition. That is, at x is equal to 0, at t is equal to 0, x is equal to 0. So, substitute natin yon. That's 0 is equal to c1 e raised to negative 7 times 0 plus c2 of, times 0 is equal to e raised to negative 7 times 0. So, this is 0 na. So, we will arrive at c1 times 1 is equal to 0. So, c1 natin is equal to 0. Next, we have another initial condition. That is at x prime of 0 is equal to negative 3. So, velocity natin, we need to first take the first derivative. So, x of t is equal to c1 e raised to negative 7t plus c2 t e raised to negative 7t. Kukuha na natin ng first derivative. So, we have, ito ay e raised to negative 7t t lang to. So, ito yung kanyang derivative. That's 7, negative 7, c1 e raised to negative 7t plus c2 times t and e raised to negative 7t. Ito class ay product. So, therefore, we use product rule. We have c2 times 7, negative 7 te raised to negative 7t plus e raised to negative 7t. So, therefore, ang first derivative natin is that this equation. Now, we substitute the initial conditions. That is, at t is equal to 0, ang velocity natin is negative 3. So, we'll arrive at negative 3 is equal to negative 7c1 e raised to negative 7 raised to 0. This is 0. This is 1 pala. Plus c2 times 7 times 0 e raised to negative 7 times 0 plus e raised to negative 7 times 0. So, ito ay magiging 0 na. Tapos, ito equal sa 1. So, we'll arrive ngayong class at c2 is equal to negative 3. We substitute that. We will have a particular solution that is x of t is equal to negative 3 te raised to negative 7t. Now, ang tanong class, at 0.2 seconds daw, what is the instantaneous velocity? So, substitute lang natin. However, take note, ang hinahanap nga pala is instantaneous velocity. Hindi natin basta-basta isa-substitute dito. Kasi kapag sinubstitute ko yung 0.2 dito sa equation na to, ang makukuha ko is displacement, not velocity. So, to get the velocity, we need to take the first derivative of this equation. And that is, so t e raised to negative 7t is again a product. So, ang x prime of t natin is negative 3 e raised to negative 7t minus 7t e raised to negative 7t. Now, ito na ngayong class yung equation natin for velocity. We can now substitute t is equal to 0.2. Kasi yun yung gusto nating malaman, the instantaneous velocity at 0.2 seconds. We have x prime is equal to negative 3e raised to negative 7 times 0.2 times 1 minus 0.2. So we will have x prime is equal to negative 0.59 meters per second. So therefore, yung velocity natin is 0.59 meters per second. So ang nakuha natin ay negative. So ibig sabihin, at time is equal to 0.2, ang movement ng mass natin is going up. Kasi kaya negative siya. So it is moving in an upward direction. Now, this is the last case for damp vibrations, and that is the underdamped vibrations or oscillations. So kapag underdamped, so nakuha niyo na siguro yung trend, kapag real and distinct, overdamp. Kapag real and repeated, critically damp. Kapag ka naman imaginary ang roots mo, you are underdamp. So for the underdamped class, yung general solution mo has a form x of t is equal to e raised to negative alpha t times c1 cosine beta t plus c2 sine beta t. Wherein yung beta nating class is equal to is equal to the square root of 4mk minus b squared over 2m, and alpha is equal to b over 2m. So ito na lang yung susundan natin. Hindi na natin kailangan na i-derive pa. We just have to follow this formula or this general solution. You get the ano naman already of how we solve for differential equations. So kapag ang pinag-usapan natin ay underdamped vibrations, so ganito yung itsura niya. So if this is your mass, mag-oscillate siya. But the oscillation will eventually die down hanggang ma-reach na natin yung equilibrium point natin. Now, in underdamped systems, do oscillate, reflected by the sine and cosine terms of its solution. So ito medyo obvious na may oscillation tayo. Kasi di ba we have sine and cosine terms. And sine and cosine terms, sabihin, meron tayong graph or figure na ang movement niya ay sinusoidal. However, we have this exponential term, e raised to negative alpha t. We have e raised to a negative number. Now, kapag tumataas ang t, so you are going to the right of this graph, tumataas ang t natin. Tumataas din yung negative exponent ng e natin. So, ibig sabihin, itong e na to approaches 0. So, ibig sabihin, as time passes, e raised to negative 80 approaches 0, minultiply mo sa c1 cosine beta t plus c2 sine beta t. Ang tendency, this will also approach 0. So, hence, ganito yung itsura niya. Habang nagmo-move ka to the right, pataas yung time, paliit ng paliit yung value ng e raised to negative 80 mo. Tapos, pag minumultiply mo siya dun sa cosine and sine terms mo, paliit din ng paliit yung oscillations natin. So, ganong class kapag underdamp yung ating system. Now, take note class na as time passes, ito ay approaching 0 pa din. Kasi di ba abot sa point na yung t mo sobrang laki niya na yung yung e raised to negative 80 mo will be equal to 0 already. So this will be approaching 0. So, apply natin sa problem. An object with a weight of 16 pounds stretches a spring by 3.2 feet. The damping due to air resistance is equal to the instantaneous velocity of the mass exerting the force. Find the equation of motion if the mass is released from rest at a point 9 inches below equilibrium. What is the position of the mass at 0.2 seconds? So, let's now try to solve. So, again, ang equation natin is mx double prime plus bx prime plus kx is equal to 0. Can we find m? Yes, we can find m kasi given tayo ng weight. Can we find b? Yes, b is actually given. Ang sabi dito is the damping daw due to air resistance is equal to the instantaneous velocity. So, therefore, the damping force mo, ang damping natin is Fd, di ba? Tapos, equal daw siya sa velocity. So, therefore, yung B mo is equal to 1. Kasi, yung damping mo is equal to the instantaneous velocity. So, therefore, B natin is 1. Now, K, we can also get that because we were given the displacement of the spring which is 3.2 feet. So first, we find the spring constant. So we use mg is equal to kx. Mg natin is weight and given yon weight talaga nakasulat of 16 pounds. So and that is equal to k times the pag-stretch nung natin, spring, that is 3.2 feet. So we have k is equal to 5. Now we can solve for the mass given yung weight natin. W is equal to mg. This is English, so g natin is 32. M natin is 1/2. So kailangan, familiar na, no? Kapag sinabing weight, W yan. Kapag sinabing mass, M yan. So we can now substitute this to the equation. We have M natin is 1/2, B natin is 1, and K natin is 5. So simplify natin, we will have x double prime plus 2x prime plus 10x is equal to 0. This is your equation. We can now find the general solution. The auxiliary equation natin, class, is, okay, so general solution na agad tayo. Huwag na tayo mag-auxiliary equation. So we have x of t is equal to e raised to negative alpha t c1 cosine beta t plus c2 sine beta t. So remember, it was also given that ang alpha natin and beta is equal to the square root of 4mk minus b squared over 2m. So we can substitute already and solve for beta. So 4 times ang m natin is 1, k natin is 10, minus b natin is 2. So we have 2 squared over 2. So we have beta is equal to 3. Now, for alpha naman, class, that is b over 2m. B natin na proportionality constant over 2 times mass. So we will arrive that is just 1/2. That is not 1/2 pala. That's 2 over 1. So 2 over 1 times 2. So we have alpha is equal to 1. Now, the general solution natin ngayong class is substitute na lang natin. We have x of t is equal to e raised to negative t times c1 cosine 3t plus c2 sine 3t. Now, we have two sub-arbitrary constant. We need two initial conditions. So the first initial condition natin daw, class, is that at x is equal to 0 or at the mass is released from rest at a point 9 inches below equilibrium. So therefore, 9 inches, your spring is displaced 9 inches at the start of your system, and that is at t is equal to 0. So at t is equal to 0, yung x mo ngayong class is 3 over 4. So substituting, so we have 3 over 4 is equal to e raised to negative 0, c1 cosine 3 times 0 plus c2 sine 3 times 0. This is equal to 0. This is equal to 1. So we have 3/4 is equal to 1 times c1. c1 natin is 3 over 4. Next, we need to use the second, we need another initial condition. Now, ano yung pwede natin gamitin na another initial condition? So, sabi dito, class, is wait, but parang walang instantaneous velocity. Okay, so hindi given, hindi siya sinabi dito. 'Di ba na may initial velocity tayo, hindi na in-specify na may instantaneous velocity tayo sa beginning of the at the beginning of your system. So, but take note, class, if it is not given, we can already assume na nagsa-start na wala tayong initial velocity at t is equal to 0. That is another assumption na gagawin natin. So therefore, we can use an initial condition that at t is equal to 0, you have no initial velocity. So that is x of prime of 0 is equal to 0 as well. Now, in order for us to use that, we need to first take the first derivative of our x of t. So, to get this, i-rearrange natin siya. So, we'll have x of t is equal to c1 e raised to negative t cosine 3t plus c2 e raised to negative t sine 3t. Para lang mas kitang-kita yung product, which is e raised to negative t times cosine 3t. And in this term class, that's e raised to negative t sine 3t. Okay, we use product rule. So we will have x prime of t is equal to c1. This is just basic calculus. E raised to negative t minus 3 sine 3t minus e raised to negative t cosine 3t. Product nito. Next is c2 e raised to negative t 3 cosine 3t minus e raised to negative t sine 3t. This is the derivative of this product. Now, we substitute. Hindi natin kailangan simplify kasi mas madaling i-simplify kapag na-substitute na natin yung initial condition. So, substitute na natin at x prime of 0, that is equal to 0. So, we have 0 is equal to c1 e raised to negative 0 minus negative 3 sine 3, 0. This will be equal to 0 minus e raised to negative 0. This is equal to 1. Plus c2 e raised to negative 0. 3 cosine 3, 0. This is equal to 0 to 1. And e raised to negative 0 sine 3, 0. This is equal to 0. So we will arrive at, we have 0 is equal to negative c1 plus 3c2. But take note, we already know the value of c1, and that's 3/4. So we can solve for the value of c2. Ba't nawala? Ayan. So, but c1 is equal to 3/4. So we have c2 is equal to 1/4. We can now solve for the particular solution by plugging in the values of c1 and c2. We have x of t is equal to e raised to negative t times 3/4 cosine 3t plus 1/4 sine 3t. This is our particular solution. Now, we were also asked what is the position of the mass at 0.2 seconds. So, the position of the mass at 0.2 seconds, direkta na natin i-substitute because displacement din yung hinahanap kasi position nung x yung hinahanap. So we have x is equal to e raised to negative 0.2 times 3/4 cosine 3 times 0.2 plus 1/4 sine sine 3 times 0.2. We arrive at x is equal to 0.62 feet, or convert natin into inches, that's 7.44 inches. So, ibig sabihin nito, class, if this is your equilibrium position, your mass class, yung mass nating class will be at the point, let's say ito yun, 7.44 inches below the equilibrium since positive yung nakuha natin. Ayan, so that is it, class. Sorry. Ayan. So that is it, class, for for spring problems in different application of higher order differential equations, tapos spring mass systems.